Hey everyone. Um so yeah, pretty happy to finally be able to be doing this stream. I'm gonna wait a little bit before I start anything just to give people some time to join because I think it might be a little tough to kind of follow along if you miss the beginning. Um so yeah, I'll just give some time for everyone. Hey Jordan, how's it going? Also, I'm gonna try something. I noticed oh, never mind. I can't change the stream latency once it's already started. Because there's settings you can do that essentially make it so there's not as much of a delay between the recording and when you see the actual video. Because right now there's a super long delay when I see the messages. But I guess I can try that another time. The problem is it messes with the audio, the video quality, so it won't be as good. Hey, Hybotics. You saw on the stream Unexpected Makers, I'm assuming. How's it going, Neil? I'm glad you made it. You had a small part in this. Hey, Matten. How's it going? So I guess here I can let me let me go over the project that I'm going to be using for this. It's not the one that Neil had sent. I went with just a different open source project. Hey, Sion, yes, I noticed the reason I was thinking about changing the latency is because of your stream. I noticed how the messages were so much less delayed, and that was pretty nice. And I realized it didn't really affect the video quality as much as I thought it would, which is cool. All right. So, the project that this is going to be based from is an open source Nucleo project. It's literally just like a Nucleo board with an STM32, I guess F7, H7. I really honestly didn't look into this too much, other than just it was an open source and it used KiCad 5, which is important. Um, and so also something else before I get in, because I'm gonna be referencing Neil a lot. He's in the stream. He is in the Discord, and obviously, if you're not already in the Discord, you seriously should be in it. And this KiBot plugin, so it's a project that was around a while ago that this guy John Beard started, and then it was forked by this other guy who's developed it since then. And basically, KiBot is essentially built for Linux distros completely. You can, in theory, get it working with Windows because, of course, you can. It's just the Python versions that this uses and KiCad uses. KiCad's still on Python 2, which when it switches fully to KiCad 6, it should work better. But Neil, who's in the Discord, essentially figured out this whole way to get it to still run basically on Windows and then also using GitHub Actions, which is the real game changer. But what I was getting at with this, in theory, I went through this, and Neil, correct me from what you had seen. So, like, if you look, it does say a lot of stuff for KiCad 6 on here, but I've tried it with a couple KiCad 6 versions or a couple KiCad 6 projects, and it didn't work. So I don't know if something in one of the latest nightlies broke it or not, but from what I could find, it only worked with KiCad 5, which is fine. I mean, that's all I use in any of our client jobs anyway. But just something to note that this, as far as I could tell, it doesn't work with KiCad 6. Jesse, I was the one asking on Discord about the plugin. Yes, I actually looked back. I was curious, trying to remember who actually posted, and I noticed that you did. So, yes, you started this whole endeavor. So I appreciate that for sure. So yeah, so this is the Nucleo board that it's going to be based on. And what I did, I titled it. Come on. So what I did is I forked it at first, but for whatever reason, the fork didn't really work. I forget why I changed it, but I just uploaded it to GitHub just separately, so it's in a separate repository, and that's what I'm going to be using for showcasing all of this. Hey JF, how's it going? Oh, you've been using it on KiCad 5? Oh, I didn't know anyone else on Discord was using it. Very cool. So I guess I can also go through the board a little bit. Again, I want to give people maybe like 5-ish, 10-ish more minutes, just to make sure everyone who's going to join is able to join. The schematic is pretty bare bones. I don't like how he doesn't fill in the background. It's super hard to read because it's not as contrasted unless it has the yellow background. Um, but yeah, I mean, it's a pretty standard STM board. He has a Blackmagic probe on here for debugging and programming, which is super cool. I'm sure looking into that would be pretty interesting. And then the board itself, or the PCB rather, let me pull that up. The board is pretty well laid out from what I could gather. He separates out the plane. So this is exactly like a Nucleo board. So you would like break it off here, but he doesn't have the little mouse bites. So I don't know. You really can't break this off. I don't know how he's intending that to work. But yeah, that's not the whole topic of the video. But yeah, pretty cool. All right. Anyone, I guess, anyone will have any questions or anything else just before I get into this? Still give it a couple more minutes if anyone just wants to talk about something in the meantime. Apparently that is a no. Okay, so I guess I can start doing this. So I kind of thought about a while. I thought a while about how to actually show this, and I was going to start from like how we would work on like the testing side and making sure everything with it works. But I think I'm going to do it from just kind of the actual like workflow wise, like how this will actually be used and how I'm planning on using it and already have with one job. So essentially, the way that our workflow works, can you go over quickly what kind? Oh, fair play. Yes, that's probably a good place to start. Um, so yes, KiBot essentially has the ability to automate scripts using these YAML files, and it conglomerates all your different like plugins. So KaiBomb, interactive bombs. It can generate Gerbers. It can do ERCs. It can do pretty much any plugin or anything that's available with Python through KiCad. And the main gist of this, which is super helpful. So like when we are doing a design and we have to export the Gerbers, depending on who's working on it, if one of us exports Gerbers and we don't have the same file structure or the same settings when we do the exports, we could have some of the design rules wrong and it ends up exporting in the wrong format, which can be a pretty big issue. And also, when I'm going to send out like progress reports to clients, it's super nice to be able to get a consistent file generation. So KiBot essentially allows you to write these YAML files, which they have an example down here. So they let you write these YAML files, which lets you export just by running this script. It lets you export like a bill of materials. It lets you export your Gerbers. It lets you export all different files and you get to set what your file format and design rules are. So every time you do this, it's consistent. So basically, you write this script one time, and every time you finish a board, it's going to export in the exact same way every single time. So it's a way to just make sure everything stays super consistent. And that's something that is incredibly helpful. And it's something that's been in like the software world with like automated tests for quite a while. Like when you would do a merge to one of your get or pull requests from something in a repository, it would run an automated test to make sure it passes everything. And this essentially allows you to kind of do that. But yeah, that is pretty much the overview. I've been thinking of learning KiCad but haven't started yet. Well, you should. What are you using then? Hybotics, I assume Eagle. So yeah, hopefully that was a good enough overview. So again, I'm gonna start just from like a super high level view, not actually go into how it works and just kind of the end game, like when you get it set up, how useful it is, and from the perspective of how I'm planning to use it with our jobs. So basically, when we're doing a design, we're obviously working on the schematic first, building out all the components and everything. And if I am doing this and someone else who works with us, if I need to get them a part of the schematic or something to do like a design review, I will export the schematic as a PDF and oftentimes a full bill of materials to be able to show them. So then they can say, oh, okay, JTAX, you have not missed a single thing. That's why I'm kind of, and yeah, I still see the problem is I still see people joining. So it's like I don't really want to get into this too much because once I start going through the process, it might be hard to catch up. But I guess it has been 12 minutes already. So throughout the schematic design, we're constantly exporting PDFs of the schematic, and we're also exporting bill of materials. The other reason we do that a lot is if I have a question for one of our clients, or I just like to give them a progress update of where we're at, I also have to then be doing PDFs and bill of material exports. And obviously, it's not the end of the world. You go here, print it, you do your bill of materials, but it can obviously be streamlined. And something that I always forget to do is update the date and update the version of your PDF. And that is something that Neil figured out with not really KiBot. This is just a string replacement in GitHub, which is super useful. So, all that said, so the way the new workflow will work is, oh, give me a second. I need to exit out all these others. Okay. So, and this is just using Git Kraken, which is the GUI Git manager that I use. So basically, when we're doing a board design, so I'm working on the schematic, I'm making commits as I go, and I'm pushing everything to GitHub. So now, use Fusion. Yeah, I've heard some people using that. Hey, T Electronics, how's it going? Can KiCad import stuff from Eagle? I believe it can. I don't know exactly how well it does. Jesse, I saw another thing. They use a string replacement to include the Git hash. Yes, we can do that with this setup super easily. Right now, we just don't have it set up. It's only doing dates and versions, but we certainly can. Mike, how's it going? Mayton, hate to nudge, but still waiting for the MC. It's getting close. I would say, actually, it is really close. So, on a little bit of a tangent, but the evaluation board that I did on stream with the buck converter, I'm thinking that's going to be one of the first, if not the first, videos on the EMC series, and that'll be here in the next week or so when they get back from their holidays. So hopefully in the next little bit. Neil, you'll see in a little what Kyle's going to show, though it's version, not git hash. Yep, exactly. But we could obviously add the git hash also. So all that said, so let's say I've been working on this schematic. I'm at a stopping point and I need to get a formal design review from my team, or I need to send it to the client to have them take a look at it. So first thing, and this is what Neil was saying, and this is what we were saying with the git hash. So for the issue date, I just put double parenthesis or double percent date, double percent, and then same with version. So now I no longer have to touch the date or the version, and now everything is pushed to GitHub. So now we go to the GitHub Actions, and I have 3 workflows here. And for this one, we won't touch that for a second. These 2 have the ability to run a workflow. So if I go ahead, and I meant to get all these deleted so it'd be a lot cleaner. Not that it really matters, but this was just from when I was testing earlier today. Which is nice that they actually let everything get deleted. Okay, so I need to generate the schematic, so I'll go here, run workflow. I can set what the version is that I want to call this, and for this, since it's not a finished schematic, pre-release, I guess, works as well as any, as well as any. So then I hit run workflow, and then one weird thing that I don't like, oh, it does update. Okay, sometimes it doesn't. So now essentially what GitHub Actions is doing is it's spinning up a virtual machine in the background that's running the KiBot software that we have set up. So it's doing all this on a separate server. Nothing's running on your computer. So what's awesome about this, and one of the other reasons I'm starting with this side, is when I got KiBot set up today on this computer, even though I had already done it on my other computer, it was kind of still a pain and I ran into issues. This doesn't matter. This can be run on any computer because it's running through GitHub. So as long as you have those introductory scripts that are set up, you don't have to worry about anything. So we let this run, and it takes like a minute, I think, for the schematic to be done. Okay, so now everything is done. So it sets up job. All this stuff is getting everything set up on GitHub's VirtualBox. Then it grabs the date and time, sets the schematic version, sets the dates, generates documentation, archives it, and then so archives means it uploads it. So now we go to this workflow, and we have a single zip file which was uploaded. So we can open that up, and we get a single text file, which gives us, one second, which gives us a full ERC that was run on the board. And this is where I don't know why he has so many ERC errors. That's really bad. I haven't seen a schematic in a while that's had that many issues. Yeah, I don't know how you mess up a pin assignment that bad. No, now I scrolled, so it's going to freeze. So this is one thing, you want to have a clean ERC, but this is something, and again, Neil, correct me if I'm wrong, I'm going to want to open up a feature request. So basically, and from what I gathered, there's no way to change this. An ERC error does not cause a failure for KiBot, but a DRC error does, and there's no way to change that. That should be toggleable, because if you want ERC to fail the test, it should, and vice versa, and same with DRC. But so basically, again, we get this single output, and now in the schematic folder, we get 2 outputs here. The first is a PDF of the schematic, and what is just so freaking cool is it string replaces the date with today's date and the current time, and then it also string replaces the revision. So to the point of whoever, Jesse said that. So if we wanted to do a revision with the git hash, we totally could. I don't think it's needed because of the way we're handling the releases, which I'll show you. I'll show you in two more steps. So now we have a fully exported schematic. Your head is blocking the revision. Good point. Um, that's funny. Okay. Why did the date go away? Oh, come on. Come on, Acrobat. You got this. Oh, this is where I didn't change it for all sheets. Oh, that's my fault. My bad. So if you're doing multi-sheets, for it to do a multi-sheet string replace, you obviously have to set the version of both. And sorry for butchering this so bad, it's hard to move it. Okay, here we go. So you can see the date is here, and then the revision is pre-release. So Tomas, can you get git tags instead? Yeah, that's what we were saying. Jesse, where does it get the version? Yes, that's what I'm gonna show you next. So again, my goal here is to do the high level, not get into any intricacies of how it's actually doing it. And then after, I'll show all the files and how this is all set up. So again, this is the reason the second sheet doesn't have the date or the version is not a problem with KiBot. It's simply because on the schematic for this sheet, I just didn't highlight it here, so that's just my fault. I needed to. And then the last file in here is our bill of materials. So open up here, and it exports our bill of materials. And all of these columns and everything are completely configurable to however you want it. So the beauty of this, any options, export, schematic, some additional. Oh, guys, I'll get there. I'll get there. If it's an option in KiCad, then you should be able to tons of export. Yes, yes. Again, I don't want to be repetitive, but I'm just trying to show what my workflow is and how I'm planning on using it. I'll go over a lot more of the details after and show exactly what you can change. So again, for my use case, in a single click on GitHub, I wait literally a minute, minute and a half, and I have a single zip that I then can send off to the client. I can send to anyone for a design review, and it has all the important information on there. So that's how I'm planning on using it a lot for the schematic side. So now let's say the schematic, let me get rid of these. Let's say now the schematic is finished. Oh, get out here with your symbols. Yeah, that's gonna error them. The joy of pulling from a remote repository. So now let's say that the schematic is finished and we're working on the PCB. So in my job, the way that we usually work is I'm one of the main people who will do the schematic designs. And I do some PCBs, but normally Gary, who's been in the streams and is on Discord, he does most of our layouts. So when I finish the schematic, I will then have him, he obviously pulls from GitHub, he will start working on the PCB. And when he finishes the PCB, we like to do a separate Gerber review in, I have Fab 3000 or he has Cam 350 to do a separate ERC or separate DRC and DFM to make sure there's no issues with the PCB. And an issue that we run into, like I mentioned earlier, if he exports Gerbers in a different way than I typically do, they're going to be different. So it's super annoying when he finishes the PCB. I often have to export the Gerber, then I have to or Gerbers, then I have to have him go and do a DFM on his side. And then if there's any issues, he has to fix them. Then I have to export the Gerbers, and it just becomes a pain in the butt. So that is what the next action that I set up is. So he finishes the PCB, he pushes it to GitHub, and now on here you can generate review Gerbers. So again, run workflow. You can do the same design reversion, whatever you design version with whatever you want. And now this one I think takes a tiny bit longer, but still around a minute. And if you notice, and obviously you wouldn't put this under the part, but that was like the only place I could find it. So here I do the exact same thing, version, double parenthesis, double percentage version, and then the same with the date. And it does the exact same string replacement on there. And yes, I will get to how it does that. And yes, you can do it with the git hash or whatever you want to do. But the git hash, I don't, like I said, I don't think it would be useful for the way this is set up, just because the way it handles releases is so freaking cool. And one issue with this that I don't think is really solvable without some workaround. So the way that I do designs and we have our library set up is everything is referenced locally. So all of our 3D step files are not on and referenced from GitHub. So when it exports the step file on here, it won't actually have all of those, but that is what it is. So again, it goes through generating all the documentation. And if we go back to the summary, now we have a single zip file. And here I'm just naming it PCB way because that was one of the exports that was there. And now we have our full Gerber package that we can then upload to Cam 350 or Fab 3000 and do a separate design review. And the key here again, this KiBot, so I think it's a niche use. So for me, like, I can't even explain to you how happy I am that this is working. If you're someone or a company who does a lot of designs, this is like the greatest thing ever because it ensures that every export will be identical. And that is something when you can take out human error is just amazing. Because if you're doing a design here or there, this probably isn't that big of a deal for you. But when we're doing 3, 4, 5 designs sometimes a month, it's so nice to just be able to click a button and it exports. So here's the Gerbers. I guess I can show. Yeah, I'll show it in the next one. So now we can do this as many times as we want. So Gary runs this, checks it, he finds an issue, fixes it, runs it again, finds an issue, goes back and forth until he's content with it. Then I'll go through, obviously, do a check on my end. So now we have fully reviewed the board, the Gerbers, and the raw design files. We're completely happy with it. Now, how do we actually do the final export package? And this is something that I've struggled with for a while, how to like do proper version control. And I don't know why I never thought about releases. And this is something again that Neil, obviously everything here is from what he had done, but it's something that he set up with GitHub, and it's just the coolest thing ever. So we basically make a formal release, describe it. This is a new, and sorry about the keyboard being so loud. I need to get a second keyboard that isn't Cherry MX Blues. So now we do our export or our release. So now we publish this release. So now we have a release here, and GitHub is set up to run an action whenever there's a new release. So this one takes a while because it has to do everything. I think it takes like 2 minutes or so. So it goes through the full thing and it does the schematic documentation and it does the Gerber documentation. I disagree. I only build PCBs for my personal use and only once in every while. I never do anything other than KiBot again. Okay, fair play. I was afraid I'll export wrong. Okay, cool. Yeah, so I mean, like I said, this is a complete game changer for us. So that's just what I was thinking with other people, but no, I totally get that. It's just it's again, it's so much like software. It's like you cry once, get it all set up, and then every single file you ever do will be exported in the exact same way, which that is like amazing. And another just kind of disclaimer type thing here. I've used this on and off for like a week. So the way that the workflow and everything, I'm sure is going to change, but I think it makes sense for the time being. So I'll probably do a more formal video in the future. And I'm sure with that, I'll get Neil to help like go into more of the intricate side of it. But for now, I think this works pretty well, and it shows all the ERC errors, which I don't know how you have, what, 380 ERC errors. That's kind of impressive. So here's the missing 3D model stuff that I was saying. Since it's referencing only what's on GitHub, if it's not accessible, it won't be able to have it. But I think that's remediable. So a minute and 42 seconds. So now 2 minutes after you do the release, and notice there's no files here. What it does is so much cooler. So now we go to our release. It automatically populates the outputs in your release. So now every PCB revision is tied to a release, which has your source code at that specific date and time, and it has your full exports. And something that has absolutely bit me in the butt many, many times is I am super scared about ensuring when I need to make a PCB that we had done in the past and I've done multiple revisions. I'm always super sketched out that I'm not going to be using the same exports that were in the past. So this essentially guarantees it. And this is why Jesse and whoever else asked about the Git hash. I don't think you need to, because, and now I'll show it gets exported here. So now in this release, which stays static on GitHub for all of eternity, we have our schematic, which has the exact date, and now you can see it. So it has the date, and then it has the revision that was taken from your GitHub release. So as long as your GitHub release is always the same or unique, it's always going to be tied to that exact same release or revision on the schematic. So you never have to worry about that happening again, which again is amazing. And then we have our bill of materials again. Oh, subscription canceled. Outstanding. Windows need more money. Or Microsoft, rather. Now we have renders. So it gives us our PCB render. And here is our version number and the date and time. Which, again, you don't have to have both of those. You don't have to have either. But it's super cool that you can. And you can string replace, obviously, whatever you want. And then it exports the bottom. Yeah, I don't think he realized it doesn't do what he thinks it does. I think he meant it to have a cutout here, like the actual Nucleo, so you can break it off. But he didn't do that. He just peeled back the copper. And then it has the step file. Then in PDFs, this has the PDFs of the schema of the copper, top copper, and then the next one has the bottom copper. The specific exports here, I haven't really messed with, so I'm sure I'll fine tune these a little bit more. And then it has the PCB way Gerbers. So now, anytime that you want to, you can go to your release, grab the entire package that was done at this specific date, and you can grab all of the files from it. Does it export the 3D view? Yeah, that's right here. But again, like me and Neil were saying, you literally, anything that's accessible from Python, the Python libraries in KiCad, you can do. So you can export the steps, you can do pretty much whatever you want. And everything is accessible at that specific date. Just yes, as long as the revision number is unique, which it should, git hash should not be needed. Just found it neat. It was also possible. Yes, absolutely. And that's why if it wasn't for it handling the releases this way, it would be a total, that would be awesome because it uniquely references. So the fact that now you keep these all unique, you never have to worry about any of those overlapping or not being unique. So that is how the workflow on GitHub works. And just as, like, to be clear, this is the way it's going to be used, at least for me and presumably for anybody who sets this up, this is how it's going to be used 100% of the time. So all you have to do from here is throw, which again, I'm going to go into, throw these files in here, and you don't even need the VS Code one. You just throw these in here, and it will automatically do it on GitHub. What I'm going to show now is how it's a lot easier to test and to like develop and add different exports locally on your machine. But once you get it set up, you don't have to touch anything on your machine, and you can just throw these files in any GitHub repository as long as the directory structure is correct, and it's going to handle it. So if you don't want to go through the hassle of the next part, you can always just go in here and edit all of your files and outputs on this side, and it'll work perfect. And actually, you don't even need the dev container. You only need these two files here. So now, does anyone have any questions with the actual functionality of this before I dig into the actual like inner workings and how to set this up? And I'll start with the local side again, and then can go to the GitHub afterwards, or GitHub Actions. All right, well, I guess that is a no. So I'll go ahead and show how you can easily kind of set up and mess with the outputs locally on your machine. So first you have to install VS Code, which is a IDE that allows a bunch of different extensions, which is super important. And you also have to install a program called Docker, which Docker is, and I had never really known about this until now. Docker is a super cool program it's semi recently, since Windows allowed virtualization like natively. It allows you to spin up a virtual machine in your background, and then you can use command line interface, you can use terminal, you can use all sorts of things on here to interact with that virtual machine. And then there's an extension in VS Code that is called remote containers, which allows you to essentially access that virtual machine and run whatever you want in it. And I'm not going to go into all the nitty gritty of getting this set up. One, because again, I didn't set this all up. That was Neil from Discord. And I think in the future, we should probably make a more detailed tutorial. I'm just going to kind of go through and give like the bigger picture of how this works and how actual the KiBot side works, because I think that's probably the more important side. But basically, you get Docker set up, you get VS Code set up, you get the container set up, and then you open up this repository from your GitHub account. So you're cloning the repository into the Docker instance. So your Docker instance is running, I think, Ubuntu. I don't know actually what Linux distro's on here. It's running a Linux distro, which is then able to run the KiBot setup in the background. So even though you're doing all this on a Windows machine, it's actually being run on a Linux box, which is what makes it so easy for everything to work, because you don't have to worry about all the Python crap with Windows. So the way this is set up is basically your dev container is all the stuff to run in your Docker, and what settings and everything, and how it runs KiBot. And VS Code is how it's actually called. So you have to use the command line that is in and I do, oh, right here, I missed it. So here's all your command line. So you have to use the command line interface with all the options that is in here. and that is what you are running when you go and run through VS Code. So basically, we are pointing it to whichever output. It's running DB and not Ubuntu. Okay, fair enough. Pretty close. Yes, sir. Actually, it's not virtual machine. It's a container. Virtual machine has chunks of RAM and resources from host, while in container, there's no chunking. It shares the resources. Sure, what he said. So basically, we are here pointing it to the actual KiBot YAML file that we want to run, and we're giving it the directory of where the base PCB is, and then where everything is going to be output. So then, by running KiBot in VS Code, it'll essentially go through and do exactly what was on GitHub, except it's going to output it locally here. So it saves a lot of time because you don't have to keep going back and forth on GitHub to do your development. But what you'll see, and I'll get to, all of the string replacing is done through the GitHub's actions. So that part is not done when you do it locally. But again, I'm going to keep stressing, this side you don't have to do. You can do everything from the GitHub side. This is just to make it a little quicker because you don't have to do a commit, push it to GitHub, then run it, then do another commit. You can just quickly make a change and then test it here. So now in our KiBot output, since I told it to run the full outputs, that is what is on release. So in my folder, I get PCBWay, the full Gerber exports. I get the PDFs of the PCB. So I should probably name that to like PCB PDFs. I get the renders, which is the drawing, the step file, and the top and bottom PNGs, the schematic, and then the ERC. So everything that was in the GitHub release is right here. Could you do it locally doing git commit hooks? Probably. I don't know enough about Actions. See if Neil says something about it. I mean, I'm sure you could. I don't know why you'd really need to, though, because Actions works pretty well and it's done remotely. So that's how VS Code runs it. So now we can just kind of go through the top level of what is actually being run. So I'm running the full outputs.kibot YAML. So full outputs, every file has to have a version number, which, okay. Then there's the pre-flight. So basically the pre-flight section is essentially what gets run before it does any outputs. So I'm telling it to run ERC. I'm telling it not to run DRC. And actually, I will show you this because this is what I was saying earlier. Needs to be a feature request for KiBot because this is wrong. It shouldn't be set up this way. So now it's running the DRC side. And what you'll notice is it's going to fail solely because it's not a clean DRC, which is fine. I don't have an issue with that. But from what I could gather, there's no way to control if it fails or not based on the error, which shouldn't be. What you can do, and it's cool, but it needs to be global, is you have the ability to filter individual warnings. Whoops. So you can filter DRC errors. So if you have like one or two errors that are on your PCB or your schematic, you can filter them out because sometimes you don't have 100% clean ERC or DRC. So that's useful, but it needs to be a global thing like fail on or stop running on a failed DRC, stop running on a failed ERC. But for now, I just set that to false because the board I'm using as an example doesn't have a clean DRC, so I don't really have a choice. Or you can just set up the GitHub action auto run. Yes, Tomas, I'll show that in a second because you absolutely can do that. Yes, exactly. While Kyle doesn't have it set up, I personally have mine attached to pull request. Yes, I'll go into that. I don't have a use for it, I don't think, in my workflow. But yeah, certainly you can do that. And then global, these are just global outputs for everything else. It sets the default file name for all generated files. and now the import side is what is going to be essentially run from this full outputs. So I have a full outputs, and then I also have a schematic outputs, which just depends on what exactly I want to run. And I guess technically for consistency, I should have just a Gerber outputs here, but good enough for now. Oh wait, that's another repo, but yes, it can be done that way. Yes, yeah. I'll get to that when I start going over the GitHub side. So now if we go into the include section, now this is where the actual like interesting part of it is. So the first one here is in schematic and documentation. So the way I have this set up, and this is what I changed a lot from how Neil had it, is the outer side is what's actually being called from GitHub, which is why, again, this should have a third one for just Gerber outputs, but I am still getting this set up how I want it. And then inside the schematic includes is what is run just on the schematic, and what is in the PCB side is just run on the PCB. So for schematic, we have the documentation. So the outputs, this is what the name of the output is, just locally, comment, type, it's a PDF schematic print, and then what is the name of the directory. And all of this is obviously on here on the repository for KiBot. So, what was I looking for? Did not mean to cut that. So the types of exports you can do are plot, drill, documentation, bill of materials. So all of these are based on this and what type of exports you want. So whoever had asked about step, this is all what you can export. So steps, 3 different bill of materials. You can do a PCB or a schematic print. You can do centroid data for pick and place. You can do your drills, obviously, DXFs, all of these. So pretty much everything, again, that's accessible by the raw Python scripts from KiCad are accessible here. So now for options, we can blacklist if it's a DNP or do not use. It won't use anything that's set to that. What other settings are on here, and then how the columns are set up. Again, these are how the columns are for the CSVs that I find useful. You can set those to whatever you want, and like everything, it's all on here. So like columns for bill of materials, you can see how you want it. You can do whatever columns you want. You can replace the naming however you see fit. So from the full outputs, it first does the documentation. So it will output the PDF of the schematic and the bill of materials, and it sets the directory both for schematic. So in my output under schematic, we have the CSV, which is the bill of materials, and the schematic PDF, which is the actual PDF schematic, both under the schematic directory. So now the next thing it runs is documentation for a 2-layer board. So that is now under the PCB side, and documentation for a 2-layer board, again, needs the version. Outputs the name. So this is just the front copper and user drawings. And this is something that Neil set up. I probably won't use this. I don't find that super useful, but I kept it in here because it's cool to see some of the options you have. So this exports 2 Gerbers that only has the front copper and the drawings, then a second one which is bottom copper and the drawings, and these are both in the directory PDFs, so you can see both of them here. And then we have the image of the PCB, which shows like the physical view of it, which I think is really useful. So top and then bottom, so it actually shows what this looks like. And whoops. So PCB top, that goes in the render, that goes in the render, and it's a PCB draw, which exports the step. Also, fun fact that GitHub has an online step viewer. Yeah, probably not surprised. I just created a repo for my 3D files and noticed it. Yeah, I'm guessing if you do that, then it'll be able to reference it also. The drawings are less useful for me. I have stuff where I need to make laser cut. Yeah, that certainly would be useful. And that's what's so cool about this. Again, anything that you can export from KiCad, basically, you can do on here consistently every single time, which that's what's just so powerful about it. So then step, we can set any options. Again, I'm not going to go into every single option because obviously if you want to see any of the options, you can just go here and you can set it to be millimeters or inches. Do all of these on, is the interactive HTML block? Yes, it is. That's a really good point. That's something I need to add to my release because if we're doing hand assembly for a prototype, that is super useful. So yes, you can do interactive BOM, so it'll export that out with every setting that is available, which is super cool. So back to full outputs, we've now got the schematic documentation, we have the PCB documentation, and now we have the specific export Gerbers. So now this is the way what I'm seeing is basically depending on the fab that we're using, I could have like 3 different fabs set up here, and depending on who we're actually going to use, I can just choose whichever folder I want when it's exported and go to that fab. Every time the exact same. That's what's so neat about this. So now we can go to the PCB way one and same version, outputs, Gerber, just like the one before, directory PCB way, and now options, setting the specific Gerber options. And these are all the settings that you would set when you go and export out the Gerbers and what layers you want. So the only other nuisance with this is you will also need, and what I'm probably going to do is have, instead of it being in the includes PCB or maybe down here, I'll have like 2-layer, 4-layer, 6-layer, 8-layer, and then all of these obviously have to have different layers or different design rules depending on what you're using for that fab. But otherwise, it's pretty much the same. We set how the drill exports need to be. And just to clarify, you can have it do all copper layers. So I'm just saying a 4-layer, if you have separate exports, that's where, or separate design rules, that's where that would be pretty useful. And then PCB way drill, obviously the drill exports. So that is everything on the full export one. And then the schematic outputs is what I'm running when I manually force just the schematic to be exported on GitHub. And that just does the schematic documentation, obviously. And all of those can be then run as a GitHub action. So I guess before I jump into now the GitHub side, does that all kind of make sense? Just keep in mind, since I'm running it through VS Code, it's all started from this single call here. So if I wanted to do, for example, just the schematic outputs, I can run that, and it'll just do the ERC and the schematic side. And it's done. Because all it did was the bill of materials and the schematic. I can't show just that because I forgot to delete it, so it's obviously not going to delete everything, each output. So those are the 2 main calls that will then be called from GitHub. Oh, hey, Jeremy. How's it going? Yeah, this will definitely be useful for you for sure. So that's the KiBot specific. The VS Code is for, again, just local testing. The dev container is, once it's set up, you never have to touch that. That's just to get VS Code running it correctly. So now the other useful side is the GitHub workflow. So these are the 3 specific workflows that are set up on the repository, that are set up on my repository. So the 3 workflows correspond to the 3 files that are in the workflows. And this is just something that's done natively by GitHub using Actions. So anything that's a YML file in this specific folder will automatically populate in the workflow section. So for the generate schematic actions, you have the ability to make it a workflow dispatched action, which all that means is it lets you manually run it. So here you can manually run, here you can manually run, release you can't. So if you go to the release side, which is the full outputs, it's not there. It doesn't have the workflow dispatch. So for the full outputs, this is where whoever had asked doing it on a push, you can do that here. So you can do a pull request, you can do on a push, you can do on, I forget what all the others are, merge, I'm sure, and then what the name of it is. So for generating the schematic outputs, it lets us manually trigger it. The jobs are what are actually being run, and you can see on here the jobs correspond to what are going to be here. So get date and time, schematic version, date, PCB version, documentation, and that just makes it a little cleaner to see actually what's going on. So the first job, documentation. Pull request is probably the other most useful trigger. Yes, I would assume so. So now this is just setting a environmental variable that is referenced throughout here. So base file name dot schematic is just being referenced from right here. Time zone, another environmental variable that we use when we get the current date and time, output folder, and then what the version is. Oh, and this I forgot to change. It should be referenced here. And then what it's going to run on. Neil, I was right. It is running on Ubuntu. I knew I saw that somewhere. So VS Code might be Debian. Can you bump up your zoom a little bit? Sure. Oh, Control doesn't do it. Maybe Alt? No. Um. Apparently you have to set it. Okay. So those are all environmental variables, and now these are the steps that actually get run in KiCad or get run in GitHub. So the first thing is get current date and time, get current date, set schematic version. So again, these are corresponding to the actual what's being run here. So first, it grabs the current date and time just by using an echo command to have it relate back from the Linux box what the current date is, and then sets it as the environmental variable. Does the same with date. I use this. This is something that Neil didn't have. This gets date and time, but I wanted to save the outputs with the date. And obviously, you can't use colons and all that in a file format. So I just got rid of the time part of this. Then we do a string replacement, which is using a repository that handles the replacement. So it goes through, finds the version, replaces it with the version name, goes through, finds the date, replaces it with the date that we saved before. And then, so all that is done before KiBot's even touched. So it's just editing the raw file. And Ubuntu is what GitHub uses, but it really isn't because it clones another thing based on KiAuto, which is Debian. Oh, well, still, one way or another, it's close. So now this is what actually runs KiBot. So on here, it will run the schematic outputs. So since this is just when I want to get all the outputs for the schematic side, I'm only running the schematic outputs YAML file. And then the directory is the output folder that it references, the schematic, again, just using the environmental variables, the schematic, and then PCB. And then this just uploads them. So what I added again was showing the date on the zip files. So I get on mine whoops, not that one. On here, okay, apparently not. But it shows what the current date is, and I just find it kind of useful. Yes, it obviously would not be possible if KiCad wasn't in plain text, which is so freaking nice. So that is to do the schematic outputs. Then for my Gerber review, same thing as everything else. All this is identical. And now for generating my documentation, it is running the Gerber's PCB2 layer. So this is where what I was saying with the way I have all of my KiBot files structured, I should only be calling things outside of the include. So I need to add a third file here that does Gerber outputs and call that. But everything here is exactly the same. And then generate full outputs. So this is on any releases that are published. Oh, I didn't know published. So you could do like a pre-release and it wouldn't trigger. That's super neat. I didn't even know that. And again, everything on this is identical. And then when we're actually running the KiBot side, now we're calling the full outputs YAML file, which is here. And that is outputting same thing all here. And then the last thing that is a little bit different on this one is it zips up the documentation on the top level, which yeah, okay, I just want to double check. Yeah, the others don't do that. So none of the others zip this up, and then we upload the fab outputs to the release, and that's why we had to zip it. I was confused for a second because since it gets tagged to the release, it has to be explicitly zipped. So on the release, that's how we get our outputs here, and it gets uploaded on this side. So the alternative way without using GitHub, without using VS Code, is literally you would just go and you would take the GitHub workflows and you would take the KiBot. And if you throw these two things in any repository and change the file structure and the naming just to make it reference that specific repository, it will work automatically with any GitHub repo, which honestly is probably the way to go. It's super nice to have it running on VS Code, and it's definitely quicker to make changes. But since it is kind of a hassle sometimes to get it set up, being able to just directly use it on GitHub is probably the more seamless way to do it. But if you already have VS Code or Docker set up, probably makes sense. So yeah, that's kind of KiBot in a nutshell. Does anyone have any thoughts or any questions with what's on here? This was kind of my only goal, what to go through on this stream. So at this point, other than if you guys have questions, I don't know what else we want to do. But yeah, I am so excited to keep messing with this because it is just beyond powerful. And I think getting it set up with GitHub Actions, I think, is a pretty big game changer for it. And I'm assuming it's going to start being used a lot more often just because now it's so accessible and easy to use at any time. Which it's kind of funny that people hadn't been using it that much beforehand, at least not to my knowledge. But yeah, so then I guess if nobody has any questions or anything else to go over, I'm content with making this kind of a short stream. Like I said, might do a more in-depth video down the road going into more like details on it, but once you have it set up on GitHub, I do think the documentation from the KiBot repository itself is pretty thorough. Like, I'm shocked that there is that it's this well done. I mean, you're almost never going to see any software repositories that have it this cleanly laid out. Could you auto-generate a release when making a tag? I would assume so. Um, I mean, GitHub Actions, from what I've gathered, is pretty incredibly powerful. But maybe Neil, do you know that? But that wouldn't be something specific. Oh, I'm glad I clicked that. Okay, so it is in progress supporting KiCad 6. Okay, so that's super cool. That at least at some point it will support KiCad 6, which we don't need that. I mean, obviously right now, but hopefully when it is finished, that or when KiCad 6 is released, then this will fully support it, which I assume it will. But yeah, um, depending on what you mean by auto-generate release, run the KiBot script. Sure, you can trigger them on a push and detect that it was a push of a tag. Yeah, I mean, that's what I was assuming. Alright, well then I guess I'll go ahead and end it here. I appreciate. I know this wasn't like a normal stream that I would do, and I don't know how many people really gain much from it, but I certainly know this is incredibly useful, and I think when the more people use it, the more popular it'll likely get. But with all that said, yeah, I hope everyone enjoyed this. Let me know any other questions in the comments or on Discord. And I will see you guys in the next stream. Next weekend I'll have a video going out. I don't know if I'm going to be streaming or not. I don't have anything specific. Maybe if the evaluation boards get in by that time, I'll do a video or do a stream assembling them. But up until this point, I don't have anything set up. I see the power here, but way out of my requirement. Yeah, like I said, I think this is more in tune with people who are like us, a design shop, who we're putting out a lot of designs to where having a consistent guaranteed output is worth its weight in gold. But for people who aren't doing that many designs, it's probably not that useful. But I hope everyone enjoyed, and I will see you guys potentially next weekend. Have a good one, everyone.